Okay, let's talk about regular expressions. What are regular expressions? The regular expressions are algebraic descriptions of a language. Think of it like your algebra where we have x plus y is equal to z. Um, that's just basically the law, how regular expressions work. They are used for pattern matching, for recognizing strings of a language, and so on and so forth. Um, yes, so there are certain operators in regular expressions. Operators. We have the union. Let's say we have a language L1. L1 can be united with L2 with the union symbol. The L1 could consist of, let's say, 0 or 1, 0 and 1, L1, and L2 can consist of, let's say, A and B. The union of that would be um, 0, 1, A, B. The languages can be a little more complicated than this, but that's just for the example. So we have for union. For concatenation, um, this can be represented either by nothing or the dot. The concatenation just operates such that they are attached. It's not a choice. It's not like oh, either this or this. It's this and this. You understand? Okay, and it can be represented. Let's say L1 dot L2. We have also the clean closure. Clean closure. Clean closure is represented by, let's say we have a language L. The clean closure is L star, which is just saying L to the power of 0, which is we're just going to be an empty string. Union, or is it concatenated now? It should be union. L with the power of 0, union L with the power of 1, union L with the power of 2, and so on and so forth. Where L0, let's say we have a language of the alphabet 0 and 1. L to the power of 0 would be empty string. L to the power of 1 would be the strings will just have one, the length of 1. L to the power of 2 will have strings of length 2, which will be 0, 0, 0, 1, 1, 0, 1, 1, and so on and so forth. This one can tend to infinity, and so there's not much need. We can just ln. Now we have the positive closure. Positive closure. Positive closure. This can be represented with L plus. And for positive closure, it's just the clean closure minus the empty string. So what this will recognize is the union of L to the power of 1, L to the power of 2, L to the power of 3, and so on, ignoring the empty string. So these are the primary operators that we have for regular expressions. Let me clean that up. Okay, moving on. Moving on. Yeah, we must note that there are some steps. There's some inductive steps. Inductive steps for regex, regular expressions. Number one, if we have R1 and R2 as regular expressions, then R1 plus R2 denotes the union of the languages of that regular expression, of those regular expressions rather. So we have L R1 union L R2. That's what happens when we have R1 plus R2. If we have R1 R2, which is the concatenation, as regular expressions, RE, then R1 and R2 as regular expressions, then R1 concatenated with R2 denotes the concatenation of the languages. Concatenation of the languages. Pardon my writing. Languages. So we have LR1 concatenated with LR2. If we have R as a regular expression, then R star, which is the clean closure of R, denotes the closure of the language of R. So we have L R star means L R star. I believe that might be just what we need. Now let's do some questions. Example 1. Write the regular expression over the alphabet A, B, C. This is a set of symbols. So now ABC containing at least one A and at least one B. So that's what we have. Please note that regular expressions are usually not what they seem to be. It's easy to conclude at least one A or one B, and then the solution A, B. At least one A and one B, right? But that will be erroneously, it's just going to be wrong. Why? Because there are three symbols in the alphabet A, B, C. What happens when we have a string CCCAB or ACCBC? There is at least one A, one B. There's at least one A, one B here. That means I can also have A, C, 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 A, C, B, B, B. That should also work because at least one A, at least one B, and I have way more, and that should be accepted. But here, when I say A and B or AB, this is a severely limited option, so we can't use this. So I'm just going to clean that, and so let's break it down. At least one A and one B. So we can tell that there's a concatenation there, but the arrangement might also be taken into consideration. How are we going to go about this? There are three symbols. There's A, there's B, there's C, right? Remember that when we are talking about unions, we talk about plus during the induction steps. So the plus here is signifying union. So first things first, since there's A, B, C, let's deal with the base conditions first. We must have A and we must have B. We must have at least A and we must have at least B. But then what happens when we have B before A? That should still be permitted in the language. In the language, you still also be able to allow A, B, C, 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 or B, A, C, C, C. This should also be accepted. You people want to feature on my YouTube video. God will not allow you to feature. Yes, now they are too loud. It's not going to help very much. It kind of did. Well, I can easily cut this. How does that make you normal? Back to the video. I have to cut everything out now. Now, okay, so we have A, we have B. But we can have this, we can have this. So we introduce another union here. So we have the reverse, AB or BA. AB or BA. But what do we do with the spaces in between? Because arrangements matter. There could be string, there could be a symbol before A, there could be a symbol before B, there could be a symbol before B, there could be a symbol before A. So how do we undo that? A plus B plus C star, meaning we can have 0 or more occurrences of either A or B or C. Doesn't mean there has to be anything there, right? Then for here we can also have A plus B plus C star, meaning we can have something A, B or C. This is a union, and then this clean closure means there could be an empty string, so that can also happen. And then we can have the same here, A or B or C star. This is to create a scenario where if I have C starting the string, it will work. If I have a C in the middle of A and B, it will also work. If I have a C after the A and B, it will also work. So we do the same for the second, the union on the other side. We have A plus B plus C star. Then again A plus B plus C star. Then A plus B plus C star. The clean closure of this, the clean closure of this, the clean closure of this. So if we want to test this guy, A, we could pick this, B, we could pick this, and then we could go over this 3 times and pick C. C occurs once, C occurs again, and C occurs the 3rd time. So we'll have A, B, C, C, C. So that checks out. For B, A, C, 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 we can start with a B, we can have an A, then loop C is 3 times here, we'll have B, A, C, C, C. So that checks out. That, if you do not understand, you can watch it one more time. But I believe maybe it's better to handle another question so you could familiarize with yourself with this concept. Moving on, example 2. Example 2. Say we have the alphabet containing the digits 0, 1, right? And we want a set of strings of zeros and ones whose 10th symbol from the right is 1. How do we go about this? Solution. Decipher the question. Understand the instructions. It's a string of zeros and ones. Let's say we have a language 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 0, 0, 0. How many are those? The length of this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, remember the condition. Whose 10th symbol from the right, we are counting from here, is 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have to make that a 1. Okay. So we have a 1. And so on and so forth. We can have a string of any length, but we want the 10th symbol to always be a 1. How do we design the regular expression for that? Note we don't care about the length of the left hand side. We only care about the length of the right hand side. So this can be 0, it can be 1, it can be 5, it can be 20, any amount on the left hand side, followed by a 1, then a at most, no, not at most, 9 symbols must be here, then the 10th one, then any amount of symbols can be here. So for that, it just tells me the symbols can be 0, it can be 1. So 0 or 1, remember, 0 or 1. The plus sign is the union, which means I could have this or that. Now we can have 0 or more instances of this, right? So let's just use the clean closure. The clean closure will say can be an empty string, can be 1 instance of 0, 1 instance of 1, 2 instances of 0, 2 instances of 1, or it's an instance of 0, 1, and so on and so forth. This can have as far as 0, 1, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 1. Can go that far. That doesn't really matter. We don't really care. What we're interested in is the string from the right hand side. So the requisite 1, this guy. Now how do we undo limiting the strings on the other side? It can also be a string of 0 or 1s. We don't really care, but it must be of the power 9, which means the length of the string must be 9. So here we don't care what we have. Here we care what we have, and we need to have 9. So the 10th string, this guy, is always 1. Then this guy can be anything he wants. That is the solution. Can we test this out? 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1. Then the requisite 1. Then now for the 9 strings, the 9 symbols, 0, 1, 0, 1, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, and the condition is already fulfilled. On the other hand, we can have nothing, an empty string here for this guy, then 1, then 1, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we start counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, the 10th string from the right is 1. So regardless of if there's nothing on the other side, doesn't really matter. That checks out. So moving on. Question 3, example 3. Say we have say we want to write a regular expression for the language L, where W, know your math jargon, please, know your math jargon, where W is an element of the alphabet 0, 1, star, and it's 0 more of 0 or 1, where W has no pair of consecutive zeros? Okay, that's the question. W has no pair of consecutive zeros. Solution, first things first, let's try and see what the language can be. 10101. 100 will not be tolerated because this is having a consecutive pair of zeros. So we can have any consecutive number of ones, but we must not have a consecutive number of zeros. So we are kind of handicapped there. We can have 0, 1, 0, 1, 1, 1, 1, 1. We can have the empty string. Empty string doesn't have a consecutive 0, and so on and so forth. So what would the regular expression look like? Okay, so first things first, we have to deal with how do we have consecutive zeros. How do we have this? We have this by not creating a scenario where they are blocked. So if I were to intrude the zeros with a 1 and cause that to loop indefinitely, I can have 0, 1, 0, 1, 0, 1, and it will never be broken by another 0. But then I could also have a string of ones of that length. So let's just have 1 or 0, 1. So it can be either 1 or 0, 1, and I can set this to be a clean closure of that language. But then this would never create a situation where we will have zeros. We will have 1, 1, 1, 0, 1, 0, 1, 0, 1. There will never be a reason for zeros behind this guy. So how do we address that? We will simply concatenate a 0 or empty. We are not going to do the clean closure of this. We are not going to do that. That will be wrong. We're just going to have one existing 0 because that's all we need. Look at it. We don't want a situation where the zeros are consecutive. We want just a singular 0. So what happens after we have a long string of ones? We can easily have a 0 to end it, and that will work. Or we could have an empty where we don't need to actually add a 0, depending on what the string we are trying to generate is. This is the answer. There could be other forms and varieties of doing this because the goal is to just make sure there's no consecutive zeros. So there might be another way to go about this. Moving on to another question on regular expressions. I'll do two more. So example 4 now. Write a regular expression for the language L is equal to AN BM, where N is greater than or equal to 4, M is less than or equal to 3. So let's take a look at that. Solution. Recall the conditions. N must be greater than or equal to 4. M must be less than or equal to 3. So let's generate some strings. A greater than or equal to N greater than or equal to 4. So there might be 4 or 5 A's. Let's say A, and M less than or equal to 3, which means I can have 0 occurrences of M. I could have 3 occurrences of M, but no more. B is wrong. B is also wrong. So on and so forth. So what would the regular expression look like? Regular expression would have, first of all, let's cater to A. A has to have at least 4 occurrences. So A to the power of 4, that means the string of length 4. Now what happens after that? We could have the clean closure of A again, which means 0, empty, or 1 or more, so on and so forth. You can have that has been taken care of in A clean closure. So how do we deal with B? B must be less than or equal to 3. So we can have the string of length 3 for B, could have string of length 2 for B, and string of length 1 for B. Then we can also have the empty. This is the answer. To explain, A has the length of 4, which is the minimum requirement, and can have 0 or more extra A's. B can have the length of 3, or the length of 2, or the length of 1, or the length nothing at all. That is the answer to this question. You can go through it over again. If practice is important if you want to become a master, so the same applies here. I'm just going to clean it up again. Question 5. All right, this might be a little tough. Example 5. Now say we have irregular expression, God have mercy, for a set of strings of an equal number of zeros and ones. This is the alphabet. Now the condition, such that in every prefix the number of zeros differ from the number of 1 by at most 1, meaning the length of zeros must not be greater than greater than the number of 1 by at most 1. So if we have 0 0, we must have a requisite 1 to cause the prefix to work. Or if we have 1 1, we must have a 0 to break that flow so that it can work. Because the difference between zeros and 1 here is 1. The difference between 0 and 1 here is also 1. But when I have 1 1 1, already this has destroyed the prefix here is already wrong. Why? Because there is no 0. So the difference between 0 and 1 is 3. There's no 0. And if I have 1 1 1, then 0. The difference between 0 and 1 is 2, which is greater than 1. So we can't work with this. So at most, we can only have a situation where we are having 0 0 1 or 1 1 0. And then to complete that, because they asked us for string of equal number of zeros and equal number of ones, we must have a 1 and we must have a 0 here, and this checks out. Then we can have maybe multiple. It doesn't have to be 4. It can be 0 1 0 1 0 1. This also checks out. Or 1 0 1 0 1 0. Or we can also have 0 0 1 1, then 0 1. That's 1 2 3 1 2 3. This should also check out. So having tested that out, we would want to build the regular expression. All right, so let's go again. We have the regular expression can be 0 or 1 or 1 0. Now how do we undo the in between? So what we're going to have is we're going to have the concatenation in between these guys for the sake of multiple occurrences of zeros and ones, and we have a limit where we cannot exceed the difference of 0 and 1 by more than 1. So how do we fix this? We could have an empty to show that it's just going to be 0 and 1, or we can have another 0 and 1 in between this guy, so that we'll have 0 0 1 1. That will check out from here. But then we can have multiple occurrences of that. So if I look that, we can have 0 0 1 0 1 then 1. What does this give us? It gives us three zeros and 3 ones, which checks out. 0 0 1 0 1 0 1 1 would give us 4 instances of 0 and 4 instances of 1, and it still protects the condition where the prefix difference of 0 and 1 is 1. So that will check out for this guy. We do the opposite of that, where we have the empty plus 1 0. So we'll have 1 1 0 0, which checks out 1 1 0 1 0 1 0 0, protects the condition and has equal number of zeros and equal number of ones. So that checks out. So we will just loop that and we have our answer. I think that gives us strength for regular expression. So maybe I should attempt one more question. One more question. We have example 6. Say we have a regular expression, or write a regular expression for the language L is equal to ANBM, where N plus M is even. Yeah, so that's the question, where N plus M is even. This is not difficult. We just have to understand something real quick. What happens when you add an odd number plus an odd number? Say 3 plus 3, we have 6, which is an even number, right? Let's say we have 1 plus 1, that's 2. 2 is an even number. 5 plus 5, we have 10, which is an even number. What if we had even numbers plus even numbers? Do we have odd numbers? No. Let's say we have 4 plus 4, that gives us 8, which is an even number. 2 plus 2 is 4, which gives it 3. Then 6 plus 6, that's 12. That's also an even number. So the law that must be fulfilled is this: even plus even is even. Odd plus odd is odd. Sorry, it's even also. Yeah, it's even. What makes a odd combination? When we have odd plus even, you have odd. Even plus odd, you have odd. For instance, 5 plus 2 is what? We have 7. 3 plus 4 is what? We have 7. 6 plus 3 is what? We have 9. So these are odd numbers. Because we have odd numbers, it fills the condition that says n plus m must be even. So let's write some of the strings that could exist. 0 is an even number because we can have 2 into the bracket or the parenthesis x, where x is equal to 0, we have 0. But for odd numbers, we're going to have 2x plus 1. That's the general formula for odd number. Now, if we have x is equal to 0, we will have 2 into the bracket 0 plus 1. That is 0 plus 1, which is equal to 1. So 0 is not an odd number. Odd numbers must start with 1. And we are not talking about the multiples here. We are talking about straight mathematical stuff. Odd numbers begin from 1, 1, 3, 5, 7, 9, 11, 13, 15, and so on and so forth. So examples of strings that would be correct would be B, A, A, B, 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 A, 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 B, 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 and so on and so forth. So what does the regular expression look like? Remember the formula 2n for even. Odd is 2n plus 1. Remember also that we're given a pattern an bm, so we are not going to have the reverse bm an. We're not going to have that. That's wrong. So an bm, what will it look like in a regular expression? Odd numbers, two or more occurrences of that. First things first, let's put the 2. That is AA. So A already has 2 occurrences. Now, how do we undo the situation where we have 0 occurrences of A, which is also an even number, actually? Well, I don't have to do the clean closure of that. So, the clean closure of the combination of 2 occurrences of A's would give either empty, AA, 4 A's, 6 A's, so on and so forth. That's what we're going to have. Now, remember, even plus even. Now for B will also be B star. So now 2 plus 2, 4, 2 plus 4, 6, 2 plus 6, 8, 4 plus 6, 10, and so on. But then we can also have a combination of odd numbers. So we are going to have the OR, which is a union here, not an addition. So how do we represent odd numbers in a regular expression? Remember that odd numbers start from at least 1. So we already have 1 occurrence of A. Now 1 plus 2 is what? 3. 1 plus 2 plus 2 is what? 5. So we can see that when we add 2 to 1, we increment odd numbers. So 1 plus 2 into the bracket of any variable will have an odd number. So that will give us is A, then A, the even. So what this is going to give us is A, A, 2, 2, 2, 0. So that's what we have, but that has to be added with the number of B's. So there must be at least one requisite B, and then B asterisk, where there's 0 or more, the clean closure of double B's and the clean closure of double A's. So this is the answer to this question. I hope this tutorial helps. I'll see you in another video.